What an amazing project. That was so well structured and the results were so satisfying. Recon, benchmark, checking if other people have the same issue, measurements, finding problems, digging into the code. Wow, this is amazing. One can only dream of this process. How I cut GTA Online loading times by 70% by TOS 2021. I'm a few years behind, but it's an amazing project with a very happy ending. Alright, GTA Online, infamous for its slow loading times. Having picked up the game again to finish some of the newer heists, I was shocked, sarcasm, to discover that it still loads just as slow as the day it was released. So true. It was time to get to the bottom of this. Amazing. Alright, what do you do? Recon. First, I want to check if someone had already solved this problem. I always forget to check that. A few hours into a project, few hours into a problem, I do a quick Google search, been solved 100 times. So this is great. First, I want to check if someone had already solved the problem. Most of the results I found pointed towards anecdata about how the game is so sophisticated that it needs to load so long, basically coping. Stories on how the P2P network architecture is rubbish, not saying that it isn't. Some elaborate ways of loading to story mode and a solo session after that, and a couple of mods. Yeah, all these little strategies combined could save you 10 to 30 seconds. Wow. Meanwhile, on my PC. Alright, next up, benchmark. Okay, very well done, nice. Story mode took 1 minute to load, 10 seconds. Online mode, 6 minutes flat. What could be taking 6 times longer to load? Okay. Startup menu disabled, time for the R-Star logo until in-game. Social club isn't counted. Okay. Old but decent PC. Let's see, AMD, Kingston, NVIDIA. Yeah, it's pretty good. Pretty decent. I know my setup is dated, but what on earth could take 6 times? That's what I'm saying. What could take 6 times longer to load onto online mode? Couldn't measure any difference using the story to online loading technique as others have found before me. Even if it did work, the results would be down in the noise. Okay, I am not alone. If this poll, let's check out this poll here. What is this poll? A Reddit. Your average load time, 125 for 3 to 6, 64, 6 to 10. 17 for 15 minutes plus. Holy. I wouldn't even play at that point. 1 to 3 minutes. These guys had NASA computers. Not sure it's still loading. Okay. If the poll is to be trusted, then the issue is widespread enough to mildly annoy more than 80% of the player base. It's been 7 years, Rockstar. So true. Oh, he put the results here. 81% not cool. Yeah, this is crazy. That is very sad. God tier hardware, that's what I'm talking about. 1 to 3 minutes, that's crazy. Looking around a bit to find who are the lucky 20% that get sub 3 minute load times, I came across a few benchmarks with high-end gaming PCs and an online mode load of 2 minutes. I would hack for a 2 minute load time. It does seem to be hardware dependent, but something doesn't add up here. How come their story mode still takes near a minute to load? The M2 one didn't count the startup logos, by the way. Yep. Also, loading story mode to online takes them only a minute more, while I'm getting about 5 more. I know their hardware specs are a lot better, but surely not 5 times better. Yeah, that doesn't make sense. Highly accurate measurements. Alright. Armed with such powerful tools as the task manager, okay, I began to investigate what resources could be the bottleneck. This is very well done. Nice. This is a full-blown project. Spikes for a lot of Ethernet, memory spikes a little bit, CPU spikes a lot, holy. Online unique stuff. So story mode loads everything, and then 4 minutes of online trying to just destroy the CPU. Okay, after taking a minute to load the common resources used for both story mode, yep, that's over here. GTA decides to max out a single core on my machine for 4 minutes and do nothing else. A single core? Something is going wrong. Disk usage, none. Network usage, none. There's a little, but it drops basically to 0 after a few seconds, apart from loading the rotating info banners. GPU usage, 0. Memory, completely flat. What, is it mining crypto or something? I smell code. Really bad code. Yeah, something is going wrong. Single thread bound. While my old AMD CPU has 8 cores and it does pack a punch, it was made in the olden days, back when AMD's single thread performance was way behind Intel's. This might not explain all of the load time differences, but it should explain most of it. What's odd is that it's using up just the CPU. I was expecting vast amounts of disk reads, loading up resources, or loads of network requests trying to negotiate a session in the P2P network, but this is probably a bug. Yeah, definitely. Profiling. All right. Profilers are a great way of finding CPU bottlenecks. There's only one problem. Most of them rely on instrumenting the source code to get a perfect picture of what's happening in the process. And I don't have the source code. Yep. Oh, I misread that. And I don't have the source code, nor do I need microsecond perfect readings. I have 4 minutes worth of bottlenecks. All right. Enter stack sampling. I'm not sure what that is. For closed source applications, there's only one option. Dump the running process stack and current instruction pointers location to build a calling tree in set intervals. Then add them up to get statistics on what's going on. Okay, there's only one profiler that I know of, might be ignorant here, that can do this on Windows, and it hasn't been updated in over 10 years. It's Luke Stackwalker. Let me check this out. I've never heard of this. No, this project has been disabled. All right, whatever. Someone please give this project some love, truly. So one function is taking up 40.8%. These two are taking up a lot. And then there's a bunch of negligent ones. Okay. Normally, Luke would group the same functions together, but since I don't have the debugging symbols, I had to eyeball near addresses and guess if it's in the same place. And what do we see? Not one bottleneck, but two of them. I'm guessing 48 and 22. Yeah, that's interesting. Down the rabbit hole. Having borrowed my friend's completely legitimate copy of the industry standard disassembler, no, I really can't afford the thing, gotta learn to Gidra one of these days, I went to take GTA apart. Okay. Alright, this looks odd. What looks odd? Let's see here. Proc near, db add and short near PTR. That doesn't look right at all. Yeah, most high-profile games come with built-in protection against reverse engineering to keep away pirates, cheaters, and modders. Not that it has ever stopped them. There seems to be some sort of obfuscation encryption at play here that has replaced most instructions with gibberish. Okay, yeah. Not to worry, we simply need to dump the game's memory while it's executing the part we want to look at. The instructions have to be de-obfuscated. Obfuscated. All right, let me read this again. The instructions have to be de-obfuscated before running one way or another. I had process dump lying around, so I used that, but there are plenty of other tools available to do this sort of thing. Okay. Problem 1. It's string length. Disassembling the now less obfuscated dump reveals that one of the addresses has a label pulled out of somewhere. It's strlen. Going down the call stack, the next one is labeled vsscanfn, and after that the labels end, though I'm fairly confident it's sscanf. Okay. So strlen, followed by vsscan, and then some other functions. It's parsing something. Parsing what? Untangling the disassembly would take forever, so I decided to dump some samples from the running process using x64. Some debugging steps later, it turns out it's JSON. They're parsing JSON. Interesting. A whopping 10 megabytes worth of JSON with some 63,000 item entries. What is it? It appears to be data for a net shop catalog. According to some references, I assume it contains a list of all the possible items and upgrades you can buy in GTA Online. Bitfield, category weapon mod. Okay, yeah, that makes sense. That it could be definitely some item shop. But 10 megabytes, that's nothing. And using SSScan may not be optimal, but surely it's not that bad. Well, okay, so let's what happens here. Move pointer a few bytes to the next value. 10 megabytes worth of C string in memory. Move it over. Call SSScan. Count every single character in the 10 megabyte string for every tiny value read. Return scan value, move pointer. Oh my goodness. Counting every single character, 63,000 entries for every few bytes. That's like millions. Yeah, that's going to take a while. To be fair, I had no idea most SSScan implementations called strlen, so I can't blame the developer who wrote this. I would assume it just scanned byte by byte and could stop on a null. Yeah, that's interesting. I did not know that. All right, seems like a big issue. Problem two, let's use a hash. Turns out the second offender is called right next to the first one. They're both even called in the same if statement as seen in this ugly decompilation. Who wrote this code? What intern? I was an intern. All right, problem one is parsing, JSON parse. Problem two is storing. And it's all inside of a big loop to parse all items. Yee, okay. All labels are mine, no idea what the functions or parameters are actually called. Yeah, I don't really understand this. Item 2, that's the key. Yeah, okay. Yeah, no idea. Category ID, I know what that is. Okay, interesting. The second problem, right after parsing an item, it's stored in an array or an inline C++ list, not sure. Each entry looks something like this, the hash and the item. Okay, but before it's stored, it checks the entire array one by one, comparing the hash of the item to see if it's in the list already or not. With 63,000 entries, that's n squared plus n divided by 2. Yeah, that's what I thought, millions. Let's see here, 500, 500,000, million. That's almost 2 billion checks for a 63,000 entry JSON file. Oh my goodness. Most of them are useless. You have unique hashes. Why not use a hash map? That's so true. Okay. All right, let's see what this is. Profiler shows only these two lines abusing the CPU. Okay. This only happens at the end. Does something, not sure. And then this actually inserts the item. I named it hash map while reversing, but it's clearly not a hash map, and it gets even better. The hash array listing is empty before loading the JSON, and all of the items in the JSON are unique. They don't even need to check if it's in the list or not. No way. They even have a function to directly insert the items. Just use that. Seriously, what? POC. Now that's nice and all, but no one is going to take me seriously unless I test this so I can write a clickbait title for the post. The plan, write a DLL, inject it in GTA, hook some functions, something, profit. Very true. The JSON problem is hairy. I can't realistically replace their parser. That's true. Replacing scanf with one that doesn't depend on strlen would be more realistic. Okay, so hook strlen, wait for a long string, cache the start and length of it. If it's called again within the string's range, return the cached value. Oh, okay. That's very smart. He's just making his own, like, memoized function, you know? I don't know if that's the right word, but caching basically the results and returning them instead of calculating them. Very good, very nice, very nice. Something like strlen cacher, start end, len cap to 20,000. If we have a cache string and the current pointer is within it, we go into this loop. Okay, yeah. Calculate the new strlen. If we're near the end, unload self. We don't want to mess something else up. Okay, very true. Super fast return. Very cool. Yeah, return a len. Count the actual length. We need at least one measurement of the large JSON or normal strlen for other strings. Built-in strlen. Okay. If it was a really long string, save its start and end addresses. And that's the cap. Okay, the cap is 20,000. Okay. And slow or boring return. Very cool, okay. And as for hash array problem, it's more straightforward. Just skip the duplicate checks entirely and insert the items directly since we know the values are unique. That's easier, that's much easier, okay. Didn't bother reversing the structure. No idea what this does, but repeat what the original did, okay. And then insert directly, remove the hooks when the last item's hash is hit, and unload the DLL. We are done here. Full source of POC here, and that's on GitHub. Let's check it out. Let's see what people are saying on here. 2.8k stars. POC that fixes 2 GTA Online bugs and drastically improves load times. Wow. Amazing. Results, well, did it work then? Original load time, 6 minutes into online. Fixing the duplication check, 4 minutes. JSON parser, 2 minutes. Combined, 1 minute and 50 seconds. Wow. Down from 6 minutes. That's crazy. Which is a 69% load time improvement. Nice. Why did he not use this in the title? That's such a good clickbait. Hell yes, it did. Most likely, this won't solve everyone's load times. There might be other bottlenecks on different systems, but it's such a gaping hole that I have no idea how Rockstar has missed it all these years. So true. And that's the end. TLDR, there's a single thread CPU bottleneck. Turns out GTA struggles to parse a 10 megabyte JSON file. The parser itself is poorly built. After parsing, there's a slow item deduplication routine. Rockstar, please fix. If this somehow reaches Rockstar, the problem shouldn't take more than a day for a single dev to solve. Please do something about it. Sad face. You could either switch to a hash map for the deduplication or completely skip it on startup as a faster fix. For the parser, just swap out the library for a better one. Small update. Okay, let's see this ending. I was expecting to get some attention, but nowhere near this much. After reaching the top of HN, this post has spread like wildfire. Hacker News. Holy cow, I'm a casual gamer. I was excited about it. Very cool. Thank you for the overwhelming response. I'll do more writing if something interesting comes along, but don't expect anything of this scale soon. There was a lot of luck involved. There was a lot of work involved. He slayed. He absolutely destroyed. A few people suggested spamming this post to Rockstar support. Please don't. I'm sure they've seen this by now. Very true. Very true. Comments suggested I add a donate button as they would like to buy me a beer. Very cool. I'm placing a link in the footer. He removed it. Oh no. I was going to buy him a coffee. Beer haram. Alright, update 2021-03-15. Got confirmation from Rockstar that this is getting a fix soon. Okay. Just got awarded 10k through their H1 in-game bounty as an exception, usually only for security issues. That's an amazing ending. That's great on Rockstar's end. Trying to figure out what's a W8 and how to fill it. I did try asking for more technical details, but they couldn't say anything. Okay. We'll do another benchmark on my same old setup as soon as the update is out. I'm sure their engineers won't disappoint. That's amazing. Rockstar made a good move with this. Absolutely amazing. Nice. What happened next? Is that a day later? It's a day later. Rockstar released the update, downloaded and got my first run results. Same hardware, same measurement. Rockstar logo to fully online 154. Isn't that like basically the same as what he got too? 150, yeah. Wow. So they really used his exact fix. Fully fixed, tossed, approves. Thanks again for all the coffees, and thanks to Rockstar for taking the time to look into this and their generous bounty. What an amazing project. That was so well structured, and the results were so satisfying. Recon, benchmark, checking if other people have the same issue, measurements, finding problems, digging into the code. Wow, this is amazing. One can only dream of this process. Results, and then Rockstar fixes it with a $10,000 award. I'm still waiting for Pivotal Tracker to give me my $10,000 bonus for fixing their app. but that's great. Very cool.